everyone, welcome back to another video. This is the start of the geomorphology videos. I've not necessarily followed the textbook in order of the units, but I've made the videos in a manner that I feel will help you understand the concepts a bit better. However, it is also important that you engage with the content in your textbooks and also other sources that you may find beneficial to you. In this video, I've used the grade 12 Focus Geography textbook and the Geomorphology Self-Study Guide from the Department of Education. Today we will look at the types of fluvial processes, river profiles, and river grading. Okay, let's start. Okay, so the types of fluvial processes. There are three types of fluvial processes, namely erosion. For example, here, these sides have been eroded. In which the materials are removed by an agent such as water, ice, and wind. So here it's been moved by water. For the purpose of these videos, the purpose of grade 12 geography, geomorphology, the agent causing erosion is water. Then we have transportation, in which the eroded materials are carried away. For example, here the water is transporting the eroded materials away. And then you have deposition, which is a process in which materials are dumped or deposited. So here's sediment, sand, and rocks, pebbles. This is all material that has been deposited. All right. Then let's take a look at river profiles. Right, this is the first profile. This is a longitude profile, which shows the gradient of the river from the source over here to the mouth over here. You can see the river is divided into the upper course, middle course, and the lower course. The upper course is the steeper section of the river. Over here, it is towards the sources. Vertical erosion, which is downward erosion, so downward erosion happens here, will deepen the valley. This will result in turbulent flow, or there will be turbulent flow due to an uneven riverbed and valley slopes. So maybe an uneven riverbed would be rocks in the riverbed sticking out, which will cause a turbulent flow. Also, there will be waterfalls and rapids occurring here, and these are being eroded due to headward erosion, which is backward erosion, and we'll look at this in another video. Okay, the middle course is downstream of the upper course, so this is the middle course here, and is where the river has left the mountains and the gradient is more gentle. Vertical erosion decreases and more lateral erosion takes place. So lateral erosion is sideways erosion, so there will be more erosion on the sides here. The channel therefore becomes wider. The river starts to meander, which means the river starts to bend. Okay, we will look at this in another video, but the river starts to meander due to lateral erosion, sideways erosion. Tributaries join the main stream, leading to more volume and erosive power. Volume is the amount of water. Both laminar and turbulent flow occur depending on the roughness of the riverbed and the sides. Then the lower course is the flatter final stage. You can see here, and it gets closer to sea level. Deposition dominates with very little erosion taking place here. The channel is going to be at its widest. All right. Extensive meandering takes place due to the flat surface and lateral movement of the river. Laminar flow will dominate due to smooth sides and smooth riverbed. The gradient of a river is usually steeper where it rises and gets flatter as the river flows to the sea. In theory, the longitudinal profile of a river is concave in shape. So in theory, it should look something like this. In reality, there are many changes in gradient along the course of a river. So a river will never have a smooth concave profile. Okay. Then let's have a look at the cross profile of the river. Where the gradient is steepest, in the upper course, there is greater vertical erosion. So more vertical erosion will occur here. And the cross section will be steep, it will be deep, and it will be narrow. Where the gradient is gradual, so for example here and here, the side profile will be wider and also shallower. Okay, The upper course will have a deep, narrow V-shaped valley. It will also have rapids and waterfalls occur here. The middle course will have a U-shape, and the lower course will be wide open. Okay, you can see the difference between the three. All right, let's move on. Okay, we are going to have a look at base levels. So base levels are the lowest levels to which running water can flow and erode its channel. So it's the lowest levels to which running water will flow and therefore cause erosion. The changes in gradient along the course of a river are referred to temporary base levels, because the vertical erosion of a river is slowed down temporarily. So rapids, waterfalls, lakes and dams are all temporary base levels because they delay erosion. They don't stop erosion, they just delay it. So these are all referred to as temporary base levels. Okay. Then sea level is known as a permanent base level, which is over here, or ultimate base level, as this is the lowest level to which a river will erode the land. Okay, so you can see the sea level through here. All right. Then upstream of a temporary base level, for example, a waterfall, as you can see here, this is Victoria Falls. The cross profile over here is going to be wider and more open in shape. You can see that. And there is less vertical erosion. But downstream, so over here of the waterfall, there will be a steep-sided gorge or ravine. So this is a deep, steep-sided valley. As the velocity of the water is high, there's much vertical erosion. So velocity is speed. So the faster the water flows, the more erosion takes place. The erosion will deepen the river channel. So this will the water flowing off here will continue to cause erosion, which will mean that the river channel, which is down or at the bottom here, will continue to become deeper. All right, we're going to look at river grading. A graded river is a river that has achieved a balance between its gradient, the steepness of the channel, volume, the amount of water, and channel shape, so that the river has sufficient energy to flow with erosion rates in balance with the deposition rates. The ideal shape of a graded river is concave, with a steep upper course and a more gradual gradient in the lower course. In its upper course, the river will have smaller volume, an uneven bed, turbulent flow, small channel, and more friction. A steep slope is also necessary to ensure flow. In its lower course, although it has a large load, so a load is sediment, sand, silt, pebbles, rocks that is moved by the water. So although it has a large load in the lower course, it will have larger volume, more water, an even bed, laminar flow, large channel over here, and less friction. A more gradual gradient gives the river sufficient energy to flow. You also get ungraded river profiles. This is where there's either too much erosion or deposition taking place. The longitudinal profile indicates a nick point. So nick point is here, which shows a sharp change in gradient, like waterfalls. So a waterfall will occur here, and also rapids. The profile, therefore, is not a smooth concave shape. You can see it looks very different. We are going to look at how a river can become graded from being ungraded. This would be an ungraded river profile. Vertical erosion will dominate in the upper course. Remember, this downward erosion. Headward, which is backward erosion, and vertical erosion will remove the temporary base levels in the upper course. This eroded material will be transported downstream. Discharge in the river will increase, which results in lateral erosion, sideways erosion. Middle course gradient will become less steep. Deposition dominates in the lower course because the gradient is gentle. Deposited materials fill up lakes and dams. River profile will develop a concave shape from the upper to the lower course. There is now balance between erosion and deposition, which results in a graded river. Okay, before we go on to overgraded and undergraded rivers, it is also important to know that people can upset the balance in the river. They can upset the gradient, the volume, and the shape of a river. And they can do this, for example, by building dams. But you can read more about this in the textbook on page 149. But you also need to take note of the following. A river can be overgraded or undergraded. So overgraded rivers have excess energy and they will erode their channels. Rivers flowing down a steep gradient, rivers with little friction because of their large volume or an even bed, will have a lot of energy. They will carry heavy load and they will flow quickly. But if the volume decreases or the gradient lessens or the friction increases, the river is undergraded. It does not have enough energy to flow and transport its load. As the river flows, it deposits some of its load. Rivers are rarely graded across its entire course. They can become graded in sections between temporary base levels. So for example, here the rapids and the waterfall, the dam and the lakes are the temporary base levels. Therefore, sections of the longitudinal profile are concave, which will give the profile a multi-concave shape. These are the sources I've used, as well as the images. Good luck, everybody.